So this is the last part. Okay. So if there is any second order differential equation d2y dx2 plus p1 dy dx plus p2y equals to x. This x is totally a function of x. Okay. And we know that p1 and p2 are arbitrary constant. We know that this p1 and p2 are constant. Okay. So in previous video, we discussed that if there is any function in right hand side with exponential function, then how to find particular integral. Okay. So in this video, we are going to learn that if there is any polynomial with trigonometric function like sin x, cos x, then how to find particular integral. Okay. So for this case, the particular integral will be ypi equals to 1 by f of d x to the power n into v. Okay. So for this part, x to the power n, if I want to shift this function to left side of this d operator, we have to modify this d operator in this way: x minus 1 by f of d into f dash d whole to the power n 1 by f of d into v. Okay. So if the value of n equals to 1, then our particular integral will be x minus 1 by f of d f dash d whole to the power 1 into 1 by f of d into v. Okay. Now try to understand this concept with two examples. Okay. Okay. So I hope you can solve the complementary function by yourself. Okay. So it's your job to find complementary function. Now I will explain just how to find particular integral for this problem. Okay. So particular integral will be 1 by f d, which is d square plus 4, and the right hand side part is x sin x. Okay. So there is polynomial with trigonometric function sin x cos x. So we know that if we want to shift this function, this polynomial function, in left hand side of d operator, so it will be x minus 1 by f of d. Our f of d is d square plus 4, and derivative of this, it will be 2d. Okay. So it will be d square plus 4 into 2d. 1 by f of d means d square plus 4 into sin x. Okay. We know how to calculate this separately for any trigonometric function. So first, let me first find the value of this particular integral. So just write this operator as it is. So now here the value of a is 1. Okay. And if I put 1 in the place of d square, if I put minus 1 square, so it will be minus 1 square plus 4. So we can put this value because this value is not equals to 0. Okay. Into sin x. So therefore it will be 1 by 3 x sin x minus 2 by 3 d divided by d square plus 4 into sin x. Okay. So if we derivative this sin x, because there is d operator here, so we can derivative this first. So it will be 1 by 3 x sin x minus 2 by 3 1 by d square plus 4, and the derivative of this, it will be cos x. Okay, the derivative of sin x. Now we have to calculate this. So 1 by 3 x sin x minus 2 by 3. Now here also if I put minus 1 square, so this value is non-zero value. So let me put the value minus 1 square plus 4 cos x. So therefore this value, it will be 1 by 3 x sin x minus 2 by 9 cos x. Okay, so it will be our particular integral for this problem. Okay, now it's time to solve this problem. It's a similar type of problem. First pause this video and try to solve this problem, then check the solution. Okay, so here similarly find the complementary function YCF. Okay, so let me just discuss the particular integral, how to find the particular integral for this problem. Okay, so here the particular integral will be 1 by f of d. Our f of d is d square plus 1, and let me calculate derivative of this. So it will be particular integral will be 1 by d square plus 1 into x cos x. Okay, now if I want to shift this function, this polynomial here, so it will be x minus 1 by f of d. So f of d is d square plus 1 into derivative of this, so which is 2d, into 1 by f of d. F of d is d square plus 1 cos x. Okay, so let me just calculate this part first, then I have to apply this operator. Okay, so now what is the value of 1 by d square cos x? If we know that, we can write this in the form of, okay, so the operator here is d square. Okay, so if I replace this square, d square by minus 1 square, so this value becomes 0. So how to apply this d operator for this function? We know that we have to multiply x here, and we have to derivative this function, which is 2d cos x. Okay, now we can't directly put the value of a here, because this is a function of d, not d square. So first we have to make this function as a function of d square. Okay, so how can I make this function as a function of d square? So it will be x by 2 d divided by d square. Okay, now we can put minus 1 square here, because minus 1 square is not equals to 0. Okay, then we calculate the derivative. Okay, so in next step we can write 1 by d square plus 1 into 2d, and it will be x by 2 minus 1 square. So let me write minus here, and derivative of cos x, we know that minus sin x. So ultimately it will be a positive function, x by 2 sin x. Okay, now in next step we can write x square by 2, because if we multiply this with x by 2 sin x, it will be x square by 2 sin x x by 2 sine x. Okay. Minus this 2 will be cancelled out with this 2. So ultimately it will be 1 by d square plus 1 d of x sine x. Okay. So it's a u into v function. So derivative of this function will be sine x plus x cos x. Okay. Now we can write x square by 2 sine x minus 1 by d square plus 1 sine x minus 1 by d square plus 1 x cos x. Okay. If you check the first line of this calculation, we know that the particular integral is 1 by d square plus 1 into x cos x. So in this calculation, here in the place of this, we can write y pi. Okay. So in next step, we can write x square by 2 sine x minus 1 by d square plus 1 sine x minus y pi. Okay. So we in next step, we can write 2 into y pi equals to x square by 2 sine x minus 1 by d square sine x. Again, we can't replace this d square by minus a square, because if we put minus a square here, this value becomes 0. Okay. For that, we have to calculate in this way, that x into derivative of this function is 2d into sine x. Okay. Again, we can write d and d square here. It's a similar calculation. And in next step, we can write x square by 2 sine x minus x divided by minus 2, because if I replace this d square by minus a square, so it will be minus we can write plus x by 2 d of sine x. And we know that derivative of sine x is cos x. So directly we can write cos x. Okay, cos x. So therefore, the ypi will be x square by 2 into 2. So it will be 4 x square by 4 sine x plus x by 4 cos x. Okay. And for general solution, we know that we have to add this YCF plus YPI. I already calculated this YPI. Now it's your job to find YCF and write the general solution. Now it's your job to solve the particular integral for this problem. So it's a second degree polynomial. So for that, our formula, it will be changed. So just try to solve this problem. Okay.